When dealing with Whirlpool tubs and non-metallic piping, ensuring proper bonding of the motor housing is crucial for electrical safety. The absence of a metallic water pipe necessitates alternative grounding methods. There are several acceptable options for providing this bonding. Firstly, consider installing a dedicated grounding electrode near the Whirlpool tub. This involves connecting the number 8 solid copper wire to the electrode. The electrode can be a ground rod driven into the earth. It can be a grounding plate buried underground, or even a metal water pipe if it is within 6 feet of the tub, although the initial problem stated no metal pipe. Secondly, the electrical panel ground bus can be utilized. If the non-metallic pipe is connected to a metal electrical box or panel, the number 8 solid copper wire can be connected to the ground bus bar inside the electrical panel. Thirdly, if there is an existing metallic cold water pipe less than 6 feet from the Whirlpool tub, the number 8 solid copper wire can be connected to it using a clamp or bonding lug. However, the initial problem stated no metal pipe. While connecting the bond to the panel ground is technically acceptable, it may not always be the most effective solution. A dedicated grounding electrode or connection to an existing cold water pipe, when available, typically offers a more direct and efficient grounding path. Always use Underwriters Laboratories or all listed bonding lug or clamp to securely attach the number 8 solid copper wire to the water pipe or grounding electrode. Apply an anti-corrosion compound to the wire connections to prevent corrosion and ensure a long-lasting, reliable connection. If installing a dedicated grounding electrode, it is essential to ensure it is properly installed and maintained according to local electrical codes and best practices. Always comply with all local electrical codes and ordinances related to grounding and bonding of electrical equipment. Grounding ensures a low impedance path for fault current to return to the source, facilitating the operation of overcurrent protective devices like circuit breakers or fuses. Bonding, on the other hand, connects non-current carrying metal parts to minimize voltage differences, reducing the risk of electric shock. The National Electrical Code, or NEC, provides comprehensive guidelines for grounding and bonding electrical systems. Section 250 covers grounding and bonding requirements. Article 680 specifically addresses swimming pools, fountains, and similar installations, including Whirlpool tubs. Section 680.26 outlines the bonding requirements for metallic parts associated with these installations. It is important to consult the latest edition of the NEC and any applicable local amendments to ensure compliance. Proper grounding and bonding are critical for protecting individuals from electrical hazards and ensuring the safe operation of electrical equipment. Ignoring these requirements can create a dangerous situation, potentially leading to electric shock or fire. Regular inspections and maintenance of grounding and bonding systems are also essential. Check for loose connections, corrosion, and other signs of damage. Address any issues promptly to maintain the integrity of the system. For example, if a ground rod becomes corroded, it may need to be replaced to ensure effective grounding. Similarly, if bonding jumpers are damaged or disconnected, they should be repaired or replaced immediately. Furthermore, ensure that all electrical work is performed by qualified and licensed electricians who are familiar with the NEC and local electrical codes. Attempting to perform electrical work without the necessary knowledge and experience can be dangerous and may result in code violations. Consider the specific requirements for the Whirlpool tub and its location. Factors such as the type of soil, the presence of nearby underground utilities, and the overall electrical system configuration can influence the selection and installation of grounding and bonding components. For instance, in areas with high soil resistivity, multiple ground rods may be required to achieve the desired grounding resistance. Additionally, be aware of the potential for stray currents in the vicinity of the Whirlpool tub. Stray currents can cause corrosion and other problems, so it may be necessary to implement measures to mitigate their effects. This could involve installing additional bonding jumpers or using specialized grounding techniques. When connecting the number 8 solid copper wire to a grounding electrode or water pipe, ensure that the connection is made in a way that minimizes the risk of corrosion. Use appropriate fittings and connectors that are designed for direct burial or wet locations. Also, consider using a corrosion-inhibiting compound to protect the connection from moisture and other corrosive elements. If the Whirlpool tub is located outdoors, take extra precautions to protect the grounding and bonding system from the elements. This may involve using weatherproof enclosures and connectors, as well as providing additional physical protection for the ground rods and bonding jumpers. In areas that are prone to lightning strikes, consider installing a lightning protection system to further enhance electrical safety. A lightning protection system can help to divert lightning strikes away from the Whirlpool tub and other sensitive equipment, reducing the risk of damage and injury. When selecting grounding and bonding components, choose high-quality materials that are designed to withstand the harsh conditions of the environment. Stainless steel, copper, and other corrosion-resistant materials are often preferred for grounding and bonding applications. Avoid using dissimilar metals in close proximity, as this can lead to galvanic corrosion. Ensure that all grounding and bonding conductors are properly sized to handle the expected fault currents. The NEC provides guidelines for conductor sizing based on the size of the overcurrent protective device. Using undersized conductors can create a fire hazard and may not provide adequate protection from electric shock. When routing grounding and bonding conductors, avoid sharp bends and kinks. These can increase the impedance of the conductor and reduce its effectiveness. Keep the conductors as short and direct as possible, and avoid running them near sources of electromagnetic interference. After completing the grounding and bonding installation, perform a thorough inspection to verify that everything is installed correctly and that all connections are tight and secure. Use a ground resistance tester to measure the resistance of the grounding system and ensure that it meets the requirements of the NEC and local electrical codes. Document all aspects of the grounding and bonding installation, including the location of ground rods, the size and type of conductors, and the results of the ground resistance testing. This documentation can be helpful for future maintenance and troubleshooting. Regularly review and update the grounding and bonding system as needed to ensure that it continues to meet the evolving needs of the electrical system. This may involve adding new ground rods, replacing corroded conductors, or upgrading the overcurrent protective devices. Consider the potential for future expansion of the electrical system when designing the grounding and bonding system. Make sure that the system is capable of accommodating any additional loads or equipment that may be added in the future. This may involve installing larger conductors or adding additional ground rods. When working with electrical systems, always follow safe work practices and use appropriate personal protective equipment. This includes wearing safety glasses, gloves, and other protective gear as needed. Energize the circuit before working on it, and use a voltage tester to verify that the circuit is dead. Never work on live electrical equipment unless you are properly trained and authorized to do so. In addition to the NEC, there are other standards and guidelines that may be relevant to grounding and bonding of electrical systems. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. Consult these standards and guidelines as needed to ensure that the grounding and bonding system meets the highest levels of safety and performance. Consider the potential for harmonics in the electrical system. Harmonics are distortions of the sinusoidal waveform that can cause overheating of electrical equipment and increase the risk of ground faults. If harmonics are present, it may be necessary to implement measures to mitigate their effects, such as installing harmonic filters. When connecting grounding and bonding conductors to equipment, ensure that the connections are made to designated grounding terminals. Never connect grounding conductors to neutral terminals or other non-grounded parts of the equipment. This can create a dangerous situation and may result in electric shock. Ensure that all metal enclosures and raceways are properly bonded together to create a continuous ground path. This is important for preventing voltage differences between different parts of the electrical system and reducing the risk of electric shock. When installing grounding electrodes, make sure that they are located in an area where they will be in contact with the earth at all times. Avoid installing ground rods in areas that are dry or frozen, as this can reduce their effectiveness. Consider the potential for electromagnetic interference, or EMI, in the vicinity of the Whirlpool tub. EMI can disrupt the operation of electronic equipment and may even pose a safety hazard. To mitigate EMI, it may be necessary to use shielded cables and connectors, as well as grounding techniques that are designed to minimize electromagnetic radiation. When working with underground electrical systems, be aware of the potential for buried utilities. Before digging, contact the local utility companies to have them mark the location of any underground utilities in the area. This will help to prevent damage to the utilities and ensure your safety. Consider the potential for corrosion caused by stray currents from nearby sources, such as railways or industrial facilities. Stray currents can cause rapid corrosion of underground metal structures, including grounding electrodes and bonding jumpers. To mitigate the effects of stray currents, it may be necessary to install specialized grounding systems or use corrosion-resistant materials. When connecting grounding and bonding conductors to concrete embedded reinforcing steel, ensure that the connections are made in a way that minimizes the risk of corrosion. Use appropriate fittings and connectors that are designed for use in concrete, and consider using a corrosion-inhibiting compound to protect the connection from moisture and other corrosive elements. Ensure that all grounding and bonding conductors are protected from physical damage. This may involve routing the conductors through conduit or other protective enclosures, or using heavy-duty conductors that are designed to withstand physical abuse. Regularly inspect the grounding and bonding system for signs of damage, such as cuts, abrasions, or corrosion. Replace any damaged conductors or components immediately to maintain the integrity of the system. When working with electrical equipment that is located in a hazardous location, such as a wet or dusty environment, be sure to use equipment that is specifically designed for use in that type of environment. Hazardous location equipment is designed to prevent explosions and other hazards that can occur when flammable or combustible materials are present. Consider the potential for voltage transients in the electrical system. Voltage transients are short-duration spikes in voltage that can damage sensitive electronic equipment. To protect against voltage transients, it may be necessary to install surge protective devices at the service entrance and at other critical locations in the electrical system. Ensure that all grounding and bonding conductors are properly labeled and identified. This will help to prevent confusion during maintenance and troubleshooting. Use permanent labels that are resistant to fading and weathering. Regularly test the grounding system to ensure that it is functioning properly. The ground impedance tester can be used to measure the impedance of the grounding system and verify that it meets the requirements of the NEC and local electrical codes. Keep accurate records of all grounding and bonding tests, inspections, and maintenance activities. These records can be helpful for tracking the performance of the grounding system over time and identifying potential problems before they become serious. Consult with a qualified electrical engineer or other expert if you have any questions or concerns about grounding and bonding of electrical systems. An expert can help you to design and install a grounding system that meets the specific needs of your facility and ensures the safety of your personnel and equipment. Remember that grounding and bonding are essential for electrical safety. By following the guidelines and recommendations outlined above, you can help to ensure that your electrical system is properly grounded and bonded, and that it provides a safe and reliable source of power for your operations. If you have any concerns about the safety or performance of your grounding system, it is always best to consult with a qualified electrical professional.